Hello, good afternoon, and welcome to the Global Traffic Technologies webinar on how GTT can help cities to become smarter. My name is Chad Mack, and I'm a product manager with GTT, responsible for managing the company's product portfolio and new product roadmap. With that, I get to see and hear about many of the transportation challenges facing cities today. On the flip side, I also get to evaluate, consider, and in the right cases, take advantage of the opportunities that come with solving these challenges. The concept of a smart city has created a lot of buzz in the transportation industry, and in today's webinar, I will take you through what it means to be a smart city, how this relates to transportation, and provide a few examples of how GTT technology has been leveraged in leading cities across the U.S. to make them smarter. So by now, many of you have likely heard of the Smart City Challenge, sponsored by the U.S. DOT. One of the primary goals of this competition was to spark innovation in transportation and get people in both public and private sectors actively moving forward in improving the nation's transportation system. As you can see from the attached image, it's fair to say that the competition made tremendous strides in doing just that, with 78 cities submitting applications for the challenge. I actually had the pleasure of attending the South by Southwest conference in March, where Secretary of Transportation Anthony Fox announced the finalists, and I witnessed firsthand the excitement and energy that has been sparked by the competition. Between autonomous cars, connected vehicles, and federal funding, aka money, without question, it's a great time to be in the transportation industry. As Senior Advisor Mark Dowd said at the conference, the U.S. DOT is bringing sexy back to transportation. Now, I'm not sure I'd go that far, but it's fair to say that the competition was successful in sparking excitement and innovation in transportation. With that being said, only one city, Columbus, Ohio, was selected to receive the direct support and funding to move their smart city plan forward. However, I'm certain most or all of you still have needs to improve your transportation system, and I'd like to take you through some examples of how GTT technology can be leveraged to do just that. What I'm going to take you through today are first, what is a smart city? Second, I'll walk through some of the smart city technologies offered by GTT, and then I'll wrap up with a couple examples of U.S. cities that are using GTT technology to become smarter. If you have any questions that come to mind as we go through the presentation, please enter them in the question and answer or chat sections of the webinar window, and we'll address these at the end of the presentation. So what exactly is a smart city? Wikipedia defines a smart city as integrating information and communication technology to manage a city's assets. This sounds a bit complicated, so you may be asking yourself, why is all this smart city mumbo-jumbo necessary? Or why can't we just do things like we always have? Why do we need to mess with integrating this complex technology into our transportation systems? Well, if you haven't already done so, I would recommend reading through the U.S. DOT's Beyond Traffic report, as it presents a number of very compelling statistics regarding the future of our nation as it relates to transportation. The first is that America's population will grow by 70 million by 2045. In addition, there's a trend of rural populations declining and urban populations increasing. With that, the report goes on to discuss the concept of megaregions, and it estimates that by 2050, these emerging megaregions could absorb 75% of the U.S. population. These two factors will put tremendous stress on city infrastructures that likely weren't originally designed to support this volume of people. Furthermore, the report states that by 2045, there will be nearly twice as many older Americans. So it's fair to assume that this demographic will need more and easier transportation options. Congestion also continues to increase, with the average U.S. commuter wasting 50 hours of time in traffic in 2015, leading to obvious negative economic and environmental effects. And lastly, transportation costs continue to lead in household expense, being the second largest expense for most U.S. households. This, along with changing consumer needs, is leading to a decline in private car trips and an increased need for quality transportation options. So if you believe these projections, then you likely understand and appreciate the need for an improved transportation system. But as you think about all of the services and infrastructure making up a city, the idea of a smart city can really mean a lot of things. Clean energy solutions, such as wind and solar farms, are connected to this vision, as are things like smart lighting and the concept of smart houses, with the main idea being the ability to leverage and connect systems and information across varying infrastructures to drive more effective and efficient use of resources, and ultimately improve the lives of citizens. As you can see in the image, intelligent transportation systems are just one of the many technologies associated with smart cities. However, per the statistics discussed on the previous slide, ITS technologies are at the core of smart city initiatives, as these technologies directly impact city economics and, more specifically, the ability of citizens and goods to move throughout a city. As urban populations grow and evolve, ITS technologies will ultimately enable citizens to have greater access to jobs, commerce, and vital services such as hospitals and schools. With smart city technology, cities can prosper with a number of benefits, including increased mobility for people and goods, reduced carbon footprint to minimize the environmental impacts of urbanization, and improved quality of life, with citizens having increased access to services, commerce, and jobs. All of these benefits will ultimately lead to growth in the city economy and improve life therein. So how is GTT playing a role in the smart city vision? GTT, with its Opticom and Canoga products, is considered a pioneer in the intelligent transportation space, with its history dating back to the late 1960s, when the first Opticom product was introduced to the market by 3M. Over the past 40-plus years, these products and solutions have been deployed in over 3,100 cities worldwide, making these cities smarter and safer. GTT has a deep portfolio of U.S. and international patents that set the foundation for GTT's solutions and have positioned GTT as the market leader in traffic signal priority control. In the mid-2000s, GTT acquired the Opticom and Canoga technologies from 3M and has since advanced its technology portfolio to where it is today, where GTT serves three core transportation markets: emergency, transit, and traffic, with industry-leading Opticom emergency vehicle preemption and transit signal priority solutions, Canoga traffic sensing technologies, as well as a host of advanced solutions for connecting vehicles to infrastructure, improving system operations, and ultimately leading to efficient and effective transportation system management. Emergency vehicle preemption, or EVP, and transit signal priority, also known as TSP, have been proven to provide a number of benefits, including improved travel times for emergency vehicles and buses, reduced intersection crash rates, and reduced fuel costs. GTT's Opticom product is the market leader in these technologies, providing an array of proven solutions that have been deployed in over 70,000 intersections and 70,000 vehicles worldwide. With its Canoga traffic sensing product, users have been able to improve vehicle and bike traffic flow and increase safety at rural or unmarked intersection crossings. So how do these technologies work? I will explain EVP and TSP first. To describe it simply, Opticom EVP and TSP solutions get the green light for emergency and transit vehicles. Technology-wise, EVP and TSP are very similar, with the main difference being how the existing traffic controller responds to each. In a standard Opticom EVP or TSP deployment, there are two main equipment installations, one being at the vehicle and the other being at the intersection. Vehicles are equipped with a control unit that will monitor the vehicle's location using GPS and manage radio communication with external systems. Intersections are also equipped with a control device called a phase selector. This will manage its location by a GPS, communicate with approaching vehicles, and send the necessary information to the existing traffic controller for traffic light management. With these components in place, the system can then function to provide benefits such as improved travel time, reduced crash rates, and reduced fuel costs. So how does it do this? As an Opticom-equipped vehicle travels through city streets, it is constantly receiving its location, heading, and speed information via GPS. Once the vehicle comes within radio range of an intersection, which is typically a minimum of 2,500 feet, the vehicle and intersection will begin communicating, with the vehicle sending information related to its location, speed, and vehicle type. The Opticom intersection equipment then receives this information and determines if and when a green light request should be sent to a traffic controller and ultimately the light to allow the vehicle to pass, avoiding unnecessary stops while minimizing impacts to everyday traffic flow. The Opticom family of products are comprised of a matched system of components that have been proven to work together in an efficient and effective manner. This allows cities to have different vehicle types and technologies active on the same system. For systems with both emergency and transit vehicles equipped with Opticom, there are a few subtle differences between the function of EVP and TSP that are worth noting. The first is that emergency vehicles and EVP take top priority over TSP or transit vehicles in terms of getting the green light. To expand on this, if both a fire truck and transit vehicle were approaching the same intersection and due to arrive at the same time, the fire truck would be given the right-of-way over the transit vehicle. However, within both EVP, also described as high priority, and TSP, which is often described as low priority, the systems can be configured to include vehicles of varying relative importance. For instance, a user could set fire trucks to have top priority, ambulances to have second priority, and police vehicles to have third priority, which can then be used to safely manage multiple vehicles approaching the same intersection at the same time. The same relative priority can be set for TSP systems if particular routes or transit vehicles are considered to be of higher priority than other transit vehicles. Opticom solutions also have the ability to incorporate other conditions, such as time of day or specific event parameters, to allow the system to function differently based on things like rush hour or sporting events. These timing conditions can be modified and updated over time. GTT's Opticom technologies have evolved over time from the original optical or IR-based systems, which required vehicles to be in line of sight with the intersection to function, to now using technologies such as radio and cellular to communicate between vehicles and intersections, removing past barriers related to line of sight, and ultimately allowing for more consistent, accurate, and advanced EVP and TSP capabilities. For transit systems running fixed route schedules or headways where consistency of the transit system is crucial, GTT offers software-based products to make TSP even smarter, enabling TSP only when the vehicle is behind schedule or off headway to further improve transit consistency and minimize impacts to surrounding traffic. So with these solutions, GTT has positioned itself to be the leader in TSP and EVP technologies. GTT also offers Canoga traffic sensing systems, which can be used to capture precise, real-time traffic data across your city, along with detecting the presence of vehicles and bicycles, allowing traffic managers to learn more about their city traffic networks and optimize their operations to improve overall traffic flow. Canoga traffic sensing solutions can be applied to a variety of applications, such as presence detection of both vehicles and bicycles, to support advanced traffic controller function and signal timing. Traffic counting, which also includes the ability to capture additional information such as vehicle class and speed, allowing users the ability to analyze and optimize traffic operations based on more insightful data. Data from these systems is logged and can be retrieved and analyzed from a remote or central location using GTT's central management software. This same software is also compatible with the Opticom, EVP, and TSP products, allowing traffic engineers or system managers the ability to control all GTT resources from a single central application platform. In addition to its core products, GTT has proven or prototype experience with the leading technologies that will be used to drive vehicle and signal interaction into the future. These technologies allow GTT to be more flexible in creating solutions specific for your city. A few of these technologies include open hardware and software-based systems, communication technologies such as radio, DSRC, cellular, Ethernet, and more specifically NTCIP 1211, along with central and web-based management systems for monitoring system performance, analyzing data and analytics, and system-wide reporting. With these products and technologies, GTT offers a diverse portfolio which enables us to tailor solutions specifically to your city's infrastructure and budget needs. Let's now switch gears to talk through how cities are using GTT technology to make their cities smart. GTT products and technologies have been deployed in over 3,100 cities worldwide, including 41 of the largest 50 U.S. cities. This number grows every day, and we continue to help cities across the globe in updating or retrofitting their transportation systems with the latest in technologies and solutions. Let's now take a look at a couple specific cities using this technology. The first is an EVP application for Liberty Township in Ohio. In Liberty Township, the fire department leaders were looking to achieve international accreditation for their department while improving overall service for their citizens. By improving emergency response time, the city would be able to achieve both. The township worked with GTT and chose the Opticom GPS Emergency Vehicle Preemption System to improve vehicle response time, choosing to install equipment at every intersection in the township and city of Powell to ensure that their fire trucks got the green light throughout the broader service area. The department also equipped 18 response vehicles with Opticom GPS technology. With the Opticom GPS EVP system deployed, the township was able to dramatically reduce response times, with initial tests indicating a reduction in response time for both fire and EMS by at least 40%. As you can see, these are very compelling and impactful technologies for the city. The next example is the TSP application for Memphis Area Transit Authority in Memphis, Tennessee. The Transit Authority was struggling to maintain on-time performance amid heavy congestion on two major corridors. The longer travel times were increasing fuel costs and impacting rider satisfaction. MATA worked with GTT and chose the Opticom GPS Transit Signal Priority Solution to get their vehicles back on schedule, reduce fuel usage, and improve rider satisfaction. MATA and GTT deployed technology at over 50 intersections along the two most congested transit routes. They also chose GTT's Opticom Central Management Software to manage and monitor system operations from a central location. With the Opticom GPS Transit Signal Priority Solution deployed, MATA was able to reduce bus travel times by up to 20%. Along with this, MATA now has the ability to monitor system performance from a remote location, which is expected to expedite maintenance and reduce technician trips to the field. With these improvements, MATA expects to have faster travel times and improved ridership, ultimately improving their transit services as a whole. The last example I'm going to take you through today is a Canoga traffic sensing application for rural areas in Minnesota. Within the state of Minnesota, nearly 70% of fatal vehicle collisions occur on roads in rural communities, where vehicles travel at higher speeds over varying grades and terrain. Along with this, it takes emergency responders more time to reach crash sites, given the longer travel distance, compounding the challenge of reaching injured motorists and providing medical attention in time. GTT worked with the Minnesota Department of Transportation and Minnesota Department of Public Safety to create the Rural Intersection Conflict Warning System using GTT's Canoga traffic sensing technology. The system targets intersections deemed as deadly, so those averaging 2 or more fatalities annually, by providing a visual notification to drivers at cross streets that a high-speed vehicle is approaching. For instance, picture a cross street to a highway that has a 55-mile-per-hour speed limit and vehicles approaching from around a corner or over a hill. In these instances, drivers at the cross stop often have limited visibility to vehicles approaching. With the Rural Intersection Conflict Warning System, approaching vehicles and their speed are detected in advance of the intersection. The time it will take for the vehicle to reach an upcoming intersection is calculated, and an activation signal is sent to the highly visible sign at the intersection, notifying the cross-traffic driver that traffic is approaching. With this system, cross-traffic drivers can more safely navigate and enter rural roadways. This system is being deployed across outstate Minnesota. The Minnesota Department of Transportation hired the University of Minnesota to evaluate performance. The study is ongoing. However, the Minnesota DOT is anticipating a crash reduction of more than 30% and a decrease in serious injury by 70%, improving overall safety for drivers in rural areas of the state. So to recap, GTT offers an evolving array of solutions that can be customized to meet the specific needs of cities today and into the future. Having experience with the latest technologies to connect vehicles to infrastructure, move vehicles more quickly and efficiently, and allow transportation managers to streamline operations, GTT offers a host of products, technologies, and solutions to make your city smarter. So in summary, smart cities use technology to improve life. GTT offers an array of smart city solutions that can be tailored to your city's needs, and like the examples that I walked you through today, you too can make strides to become a smart or smarter city. If you are considering ways to make your city, and more specifically, your transportation system smarter, GTT is happy to have a one-on-one conversation with you to understand the challenges and needs of your city. And we can talk through potential solutions to consider to address those needs. Following the webinar, there will be a short survey. Please provide feedback and indicate if you would like to have a GTT representative contact you. All right, so I hope you guys found the webinar useful and insightful. We'd now like to take the last few minutes here and go through a few questions that have come in throughout the webinar. So I have Andrea Thompson, the marketing manager here at GTT, to help me out. So Andrea, if you could, maybe pull a couple questions off the list and we can talk through them.
Yeah, thanks, Chad. We got a couple of good ones here. We have a few existing customers on the webinar, and they have the IR technology already. So what they're wondering about is, what are the advantages with the new GPS technology or the newer GPS technology?
Yeah, that's a really good question, and it's a pretty common question that we get because we have a long history of customers that are still on the IR technology. And so really what you want to think about with IR and the transition to GPS, there are a number of advantages in the new technology. So the first is, with GPS-based technology, you get rid of any direct line of sight requirements that existed with IR technology and light-based technology. So with GPS and our systems, what we can do is track very precisely the vehicle location and compare that to the intersection so that we can do much more accurate EVP and TSP requests and management. And so because of that, not only do you get past the line of sight barriers, so in situations where you have hills before intersections or corners, you also get improved response time because you have more predictable and timely activation with the communication technologies and GPS. Along with this, surrounding traffic is impacted less because you can time out your EVP and TSP cycles more precisely, so it minimizes the impact to everyday traffic or surrounding traffic. And then the last piece, which is it's an area that is new for GTT. We're putting a lot of effort in, and that's around the data analytics. With the new GPS-based technology, and it's not necessarily applicable just to GPS, but software in general and communication systems, we have much more access to data and analytics that we didn't have previously. And so even in the past with our GPS-based systems, we have a lot of valuable data that are stored in the logs. But then the challenge is getting that data from that equipment that's at the intersection on the vehicle and get that back into a central location. And so now newer technologies, GPS-based allows for more data. Other things like software and communication systems allow us to get that data and get it back to a central point where we can now do analytics and get a lot more insights that you just couldn't get with older technology. So a lot of good things and a good direction for us to head in with that.
Great. There's another question here on the transit side, but we talked a lot about buses. Do we support trolleys or light rail vehicles?
Yeah, we definitely do. It really comes down to a question of the application. And so in the case of trolleys and light rails, in a lot of cases, those vehicles do require TSP. And so with our GPS-based systems, they function the same as they would in a vehicle. You have the same kind of features and benefits as you would from a transit vehicle. And in the case of TSP, those extended green times, truncated red, to get those vehicles moving through intersections. So yes, we definitely support that, and we have a number of deployments on streetcar and light rail vehicles.
All right. Here's a good question too that a couple of people brought up regarding system timing. So when the fire truck arrives, how does that interrupt the signal, the coordination of the signal timing and the regular flow of the traffic cycles?
Yeah, one thing I'd preface this with is EVP and TSP are handled differently, and the way they're handled and the level of disruption has a lot to do with how the controller itself is programmed. So what our systems do is ask the controller for a green light. It still comes down to the controller to determine if and when that green light is indeed granted, but I can use an example of kind of common applications. So for EVP, it's common for a city to set up when the preemption would take place. So think about, some things to consider there. How many vehicles could potentially be at that intersection may dictate how far back you want to preempt the intersection. But then what EVP does in most cases is it will, once the controller gets the request, it will transition to the green cycle, and it will hold that green cycle until the vehicle gets through the intersection. So in those cases, it can be pretty disruptive. But as you think about newer technologies like GPS, you can get very precise around how you set your timing and how you sequence the greens and the rest of your timing, so that it's really up to the traffic controller to manage how much of an impact they want to have to surrounding systems. Contrast that now to TSP, just because it's similar. In TSP applications, it's most common, again, for the controllers to be set to do a green extension or a red truncation. So in those cases, if it really comes down to how the controller is set up, a 10-second green extension would essentially impact side streets. It would allow the green to stay green a bit longer to get the vehicle through, but compare that to EVP, where EVP will hold it, ensure that the vehicle gets through. In the case of TSP, it takes a little bit more effort to set up the system to make sure that it's sequenced in a way that will allow enough time for the vehicle to get through while minimizing the impacts to traffic. So it really comes down to coordination with our system and the traffic controller and your traffic engineering group to set that up.
Excellent. We're just about out of time. I'm going to squeeze one more question in here about, can the Opticon be integrated with the existing AVL systems, or how does this work?
Yeah, this is a very common question that we get as we think about cities and transit agencies looking for more ways to leverage their existing infrastructure and minimize the amount of new equipment that they have to purchase. So that is a strategic initiative for us to make our systems more flexible and adaptable. But for our existing systems, without question, they can be integrated with onboard systems using things like discrete inputs or J1708. Common examples of integration for us today will oftentimes integrate with AVL systems that are currently on the vehicles, and those systems will enable and disable TSP based on things like passenger loading or schedule adherence. So it really only leverages the TSP when it's needed. Then again, getting back to minimizing disruption to everyday traffic flow. So with new technologies that are available today, there's a lot of opportunity and flexibility with these systems to really maximize their value and their use while minimizing other everyday flow.
Excellent. Well, I think we've taken up the half an hour that we agreed to, so I think we should call it quits for now. But thank you very much, Chad, and thank you everyone for attending.
Yeah, and in closing out, we do want to post the webinar to make it available to everybody, and if you do have follow-up questions, we definitely want to make ourselves available to you. So we have the website listed here. I encourage you to go out there. If you have any questions about the webinar, you can review it. But then also, if you have questions, specific questions that you want addressed, you can submit them through the website, and then we'll either have a local representative follow up with you, or somebody like myself or others on the internal side will reach out to you directly to get those addressed. So thanks again for your time, and I hope you have a great rest of the day.
Thank you.